Hello guys, in today's video we're gonna solve this differential equation by using the integrating factor method. So before we get started, let's first explain the theory behind this integrating factor method. So if we have a differential equation a of x dy dx plus b of x y is equal to c of x, where a of x is different from 0, because obviously if a of x is equal to 0, then this is gonna cancel out, then we're not gonna have a differential equation, right? So if we have a differential equation of this form, what we want to do is to isolate this dy dx. So we want to make sure that the coefficient of dy dx is going to be equal to 1, right? So we divide both sides by this a of x. So we're going to have dy dx plus b of x over a of x y is equal to c of x over a of x. Now we can see that we have our dy dx of coefficient 1, right? And this is a function, this is a function, so we can write this in this form: dy dx plus, let's call it p of x y is equal to q of x, right? So this is the standard form. Now in order to use this integrating factor method, we're gonna introduce a new variable that we're gonna call mu, right? So let's introduce mu, which is equal to the exponential of the integral of this p of x, right? P of x dx, right? So this is basically exponential, so e to the power integral of p of x dx, right? Now we're gonna multiply both sides of our equation here by this mu here, right? Let's do that. So we have mu times the left hand side, which is dy dx plus p of xy is equal to mu times q of x, right? Now we can multiply out and remove the brackets, right? So this implies that mu dy dx plus mu pxy is equal to mu q of x. From here we have that mu has this value, e to the power integral of p of x dx. So let's write it down here. So mu is equal to exponential of integral of p of x dx. So now we're gonna differentiate mu, right? So we have d mu with respect to x dx is equal to, we're gonna use the chain rule, so this is gonna be e to the power integral of p of x dx, then we're gonna multiply it by the differentiation of the exponent, right? Integration p of x dx by this, the differentiation, right? Now this implies that d mu dx is equal to this, let's copy it, and this we know that integration and differentiation are mutual inverse, so they're gonna cancel out, and here we're gonna be left with just p of x, right? So basically it is p of x times this exponential, so e to the power integration of p of x dx. Now we're gonna find this differentiation of mu y with respect to x. This is a product, so we can use the product rule. The differentiation of the first, right, times the second plus the differentiation of the second times the first, so mu times differentiation of the second, right? Our d mu dx, it was already found here, so we just gonna substitute it here. So we have d mu y dx is equal to p of x, so we're gonna copy this one here, p of x e to the power integration of p of x dx, which is this, then we multiply by y, right, then plus mu dy dx. Our mu, we define it to be to be exponential of integration of p of x dx, which is basically this one here. So let's copy it down with the mu, right? So d mu y dx is equal to, so p of x, we're gonna write it down as mu, right, times y plus mu times dy dx. So we can see that here there is a factor mu, here there is a factor mu. We can factorize it, yeah? So this implies the d mu y dx is equal to mu times, we're gonna be left with p of xy plus dy dx, right? Now we can see here our p of xy plus dy dx. If we go back to the equation, you see p of xy plus dy dx, it's basically q of x, right? So let's substitute it by our q of x here. So we have d mu y dx is equal to mu times q of x. Let's write it like that. So basically this is the formula that we're gonna use in order to solve this differential equation using this integrating factor method, right? So we have this differential equation. So the first thing we want to do is to make sure the coefficient of dy dx is gonna be equal to 1, right? We're gonna divide both sides by this 1 plus x squared, right? So we're gonna have dy dx is equal to x minus 2xy, which is this right hand side, over this 1 plus x squared, right? So this means that dy dx is gonna be equal to basically this divided by this, then the second divided by this, right? So the first divided by the denominator minus 2xy divided by the same denominator, right? Because what we want to do is to also have a function which is the coefficient of the y, and then we're gonna have another function on the right hand side, right? So up to now we have our dy dx. What we want to do is dy dx. Now we're gonna bring this on the left hand side, right? So but by doing so we're gonna change the sign, so plus 2xy over 1 plus x squared is equal to x over 1 plus x squared, right? As you can see, we have the standard form that we wanted, which is dy dx, then a function and another function here, right? So basically this y, we can write it here to see it clearly, right? So now we can define our p of x, which is, as you can see, this one here, which is the coefficient of this y, as you can see in this formula. So this is p of x, right? So p of x is equal to this 2x over 1 plus x squared, and our q of x is equal to this one, right? So q of x is equal to x over 1 plus x squared. Now we need to find the mu, right? And we've said that mu is equal to the exponential of the integration of p of x, right? So mu is equal to the exponential of the integration of p of x with respect to x, right? So this means that in our case mu is equal to e to the power integration, and our p of x is this one here, so x, so 2x over 1 plus x squared dx, right? So this is our mu. Now let's try to find this integration. So we have integration of 2x over 1 plus x squared. We're gonna with respect to x, we're gonna do it by using the substitution method, right? So let's introduce a u that we say it's, let's define it to be 1 plus x squared, which is the denominator. So this implies that du dx is going to be equal to 2x, because derivative of x squared is 2x, right? Now we cross multiply, so du, if we cross multiply, dx times 2x is going to be equal to du, right? So du is equal to 2x dx, but we want dx, so dx is going to be equal to, we divide both sides by 2x, so du over dx, right? Now we can write our integration. This is equal to 2x over u, because we said that u is equal to 1 plus x squared. Now dx, we've just found it, which is du over 2x, right? So du over 2x. Now we can clearly see that they cancel out, so this is equal to integration of 1 over u du, which is natural log of absolute value of u, right? Now our u has a value 1 plus x squared, so we substitute it here. And by the way, we know that this 1 plus x squared is always going to be positive because we have a square here which is always going to be positive, and you add 1, it's clearly going to be positive, right? So then we're not going to need this absolute value. So this is equal to ln of x squared plus 1, right? So this integration here is equal to ln the natural log of x squared plus 1. So let's write our mu. So our mu is going to be equal to e to the power ln x squared plus 1. But ln and exponential are mutual inverse, right? So this is the same as x squared plus 1. So our mu has this value here, right? So we have our formula here, right, that we have proven before. Now we can use this formula. So d of mu, which is x squared plus 1, so d of x squared plus 1 y with respect to x is equal to mu, which is x squared plus 1 times our q of x, this one. So that's what we have written here. So our q of x is equal to x over 1 plus x squared, right? So x over 1 plus x squared. So these two, they cancel out, right? And also, so let's write it down like this: d of x squared plus 1 y dx is equal to x, right? Now we're gonna integrate both sides. If we integrate both sides, so we have integration of d of x squared d of x squared plus 1 y dx. We integrate with respect to x is equal to integration of x with respect to x, right? Now we have derivative here and integration here, they cancel out, right? So we're gonna be left with just x squared plus 1 y on the left hand side, and on the right hand side the integration of x is x squared over 2, right? So x squared over 2 plus constant c, right? Now we want y, so we divide both sides by this x squared plus 1. So this implies that y is equal to x squared over 2 plus c divided by x squared plus 1, right? Now this implies that y is equal to, like we did before, the first divided by the denominator and the second divided by the denominator. We're gonna separate them, right? So y is equal to x squared over 2 divided by the denominator, so we can write 1 over x squared plus 1, then the second plus c over x squared plus 1, right? So this implies that y is equal to x squared over 2x squared plus 1 plus c over x squared plus 1, and that is our result.